Hello everyone and welcome to our next Net Zero Live webinar, which is sponsored by IES. My name is Carl Brown, I'm the Assistant Editor at Housing Today, and this session is called How Can the Built Environment Move Away from Carbon Offsetting in the Pursuit of Net Zero? Around 40% of emissions come from the buildings in which we live and work, and so the built environment sector has a crucial role to play in tackling this problem. And we all know the sector is well aware of this. New research from IES shows built environment professionals want to see stronger policies on net zero. And interestingly, they think there is too much emphasis on carbon offsetting and what has been described as a burn now and pay later approach. How will we achieve net zero without carbon offsetting, and how can we work together to ensure this will happen? Where will the drivers of change come from? To debate all of this and more, I'm delighted to say we have a fantastic panel this afternoon, who I shall now introduce in no particular order. So we have Ruth Kerrigan, who's the Chief Operations Officer at IES, Connor Storkey, who's the Head of Sustainability at Mace, Jeff Southern, who's the Studio Associate Director at IBI Group, Porrick McMorrow, who's an architect and certified passive house consultant at IBI Group, and Sarah Berkey, who's the Sustainability Manager at Tilbury Douglas. Each of our panelists will speak for around 5 or 6 minutes, which should give us plenty of time to take your questions at the end, and hopefully we can have a really good debate. If you have a question for the panel, please do get involved. You can pop your question in the chat box, which you should be able to see on the right-hand side of your screen. But before we go into the presentations, we thought we would have a bit of fun and get you all thinking, and we thought we'd open a poll on one of these issues. So if we could flash the poll up on the screen, please. So we want to know what you think. Where does the biggest carbon reduction opportunity lie within the built environment sector? Is it in materials development, energy use, designed in efficiency, or micro energy generation? So if you could simply answer that poll now, please. Okay, maybe we can take the findings of that later. But that's all from me for now. I'm going to hand over to Connor Storkey from Mace, who is going to give the first presentation. Connor, over to you.
Excellent. There we go. I was just waiting for the poll to close before I could see anything. That's working. Excellent. Thanks, Carl. So I'm Connor. I work for Mace. We are a company that we're a main contractor, we're a consultant, we operate buildings, and we are a developer as well. So I work in the construction sector at Mace, and I'm going to be talking to you a bit about what we're doing to tackle net zero carbon. So hopefully you can see my screen. It's been a pretty exciting couple of years at Mace. I've been at Mace now for 7 years, and actually I've seen the fastest change in the last 18 months. I think when COVID hit, we had already launched our net zero carbon strategy, and I have to admit, I personally thought that with the pandemic hitting and going to lockdown, that was going to maybe make this less of a priority, but actually it was an opportunity for our business to look at our strategy as a whole, and redefine who Mace are and what we want to do as a business. So we turn over about £2 billion. We've got 6,500 employees globally, and the exciting bit is now our first priority as a strategy is to pursue a sustainable world, which is extremely exciting to be a sustainability professional, and we've had a great buy-in from the whole business. So we've got some three clear targets. We want to keep reducing our corporate carbon emissions. I'll talk a bit about that in a sec. 10% year-on-year reduction to get to zero. And the new and exciting target is to try and actually influence 1 million tonnes of carbon for our clients, and then also to increase biodiversity net gain to 500 hectares. Let's just see if this goes on to the next slide. Perfect. So just a bit of backstory. These are our our corporate stats from 2019 and 2020. So we've had good data for quite a while. We've been monitoring all of our energy use from all of our offices, all of our construction sites, all of the diesel use we use, all the generators. We calculate all of the embodied carbon in the developments that Mace own and operate. So all of the embodied carbon for that. When we first did this, we weren't calculating it for our construction sites, but I'll talk a bit what we're doing on that now. And then business travel, again, we're a global business, so there's quite a bit of emissions from our business travel and also waste and water. So in 2019, we emitted about 26,000 tons of carbon. We managed to reduce that down to 13,000 in 2020, which is a good reduction. I mean, the pandemic did play a big part in that, reducing business travel. And we did.
Monitor.
Oh, sorry, that's is it not showing the right screen? Apologies. I was testing that, like you said. I was talking to the wrong screen. So that was our targets, 10% year on year, and then 1 million tons of climate reduction, 500 hectares. So this makes more sense now. You can see it. We are offsetting, so I guess it's a nice one to start the debate, really. We are offsetting our emissions. We offset 13,000 tonnes last year as part of our pledge to be a net zero carbon business. Obviously, we're fully committed to getting our emissions down to zero and not relying on offsets. It was actually a decision led by our board and our CEO that is an emergency and that we needed to act now as a business. And although we've got a strategy to get to zero, we felt it was the right thing to do to offset those emissions at the moment. And we managed to partner with some really great projects around the world in areas that Mace are particularly operating in. So we have a big hub in India, South America, and Africa as well. So these are some of the projects just on there. But just to move on to where we're going, I guess, looking at our own direct emissions, so our fuel use, our energy use from our offices and stuff like that, it's pretty small fry in comparison to our influence as a business. We quite quickly realized 2 years ago that actually the buildings we build, the embodied carbon in the materials we buy, the operational energy use in the buildings that we build is where we're going to have a bigger impact. And you can see here that just a yearly opportunity. So this is per year in construct, we could influence over 150,000 tons. And in our consultancy business, we could influence nearly 1 million tons of carbon. So they're quite crude numbers, but it just puts it into perspective that actually by convincing clients to do things differently, by working with our supply chain, there's a bigger opportunity there to save carbon. Just a couple of bullet points on what we are doing. We banned diesel generators on all sites now, so that's something that's quite a big shift. We've committed to 100% renewable power on all projects. That was an easy, quick win for us as a business. And now we're doing quite detailed net zero carbon offerings within all tenders and bids, which has really benefited us to get in as early as we can. And now we're actually calculating embodied carbon on all of our construction sites, which isn't a small task, but we've been working through that this year. And I think the exciting piece as well, we're bringing our supply chain on the same journey. So we've got we've now set a target for our entire supply chain to have net zero carbon strategies as well. And then finally, last slide, we're keen to keep driving innovative solutions. Not any one of these three is going to solve our problems in one hit, but these are just some of the exciting projects we're driving to try to tackle this. So we talked about banning diesel generators. However, unfortunately, some projects still do need diesel generators where we haven't got a power supply to those sites. So we've partnered with a really innovative company, AFC Energy, and we're developing and getting the first large-scale hydrogen fuel cells on projects. Fingers crossed we'll have that on site early part of next year. So that's something that's it's not been an easy ride, because hydrogen, as you can imagine, has its challenges, especially in a construction environment. So there's a lot of work to be done there. Really excited about this, the Mace Tech innovative ultra low carbon cassette. So this is using a completely cement free product. Previously it hasn't been able to be used because of issues with code of practices and warranties and the like. So we've done full testings. We had some funding for Innovate UK, and that's now the results are coming through, so that should be ready to roll out next year. And then finally, working with schemes like Climate Group with Steel Zero. This is a commitment for the steel industry to move towards net zero carbon. From a personal perspective, I've been quite heavily involved with this, and it's been a great way to engage with the wider supply chain. We've worked with other main contractors and clients. It's a massive challenge. We hear about COP26 around, why are we still going to use fossil fuels? Unfortunately, right now, the steel industry has a long way to go before they can completely move away from steel that's from fossil fuels, and that is going to need to quite a clear route map, and that's the work we're doing with Climate Group to help shape that. So yeah, apologies for the slight error at the beginning. You could tell I was doing a bit of research on my other panelists before the call, but that's it from me. Cheers, Carl. Oh, I think you're muted as well.
Yep. Thank you very much, Connor. That was a really great rundown on the whole range of activity Mace is doing in the drive to reach net zero. And for me, that kind of really hammered home the scale of the challenge, apart from anything else. I think we're now going to go to Sarah Berkey of Tilbury Douglas. Sarah, over to you.
Lovely. Thank you very much. Let's see. I think that's correct. Yeah, so thank you. My name's Sarah Berkey. I work for Tilbury Douglas. Tilbury Douglas are a construction, infrastructure, and engineering company and a main contractor, similar to Mace. We have 2 targets. So the first is to be net zero in our own operations by the end of 2023. And our next is to be net zero, including our wider scope 3 emissions by 2040. So that includes our supply chain and end users in the buildings we build. So our targets have a key focus on the reduction of our carbon emissions, and we measure this through carbon intensity. So for us, that's tons of CO2 equivalent per million pounds of turnover. And this is also supported through ISO 14064 Part 1 certification. So this is where we have our greenhouse gas emissions audited to ensure continuous reductions. But at the moment, we're limited by current technology. Connor did mention quite a bit of this just now. So our targets do currently include offsetting as an interim solution. But when we offset, we know that they're not all equal. So we will make sure we do the proper process to make sure that the offsets we're purchasing are only for us and not being used by other companies. But we also want to mention that, these changes aren't going to happen overnight, and we want to do something now, even if it may not be the best solution, 50 years from now. And any new solutions that we have, there's always going to be a risk there. So any new materials used, any new more sustainable equipment. I mean, we could look at hydrogen, for example. We always need to have some risk assessments with that, because we don't want to compromise the quality or safety of our projects. But I think something that will really push us away from offsets in the future is actually the price of offsets. Based on some conversations I've had with offsetter providers, it seems like in the next 10 years, the price of offsets will continue to increase drastically. And when you consider our wider scope 3 emissions, they probably will account for maybe 90% of our emissions. We don't have our total emissions scoped yet, but we assume it will be a large proportion. Offsetting won't be financially feasible, so we really think that this will encourage further collaboration in the near future. So that leads me to collaboration is key. I know this is said over and over again, but it is really important. We need to work with our competitors. We need to start sharing our methods and our processes and work together to solve challenges. I know this is already happening to a certain degree, but I believe we'll start doing this in the future more. We also want to support our supply chain. A lot of our supply chain, they're smaller businesses, so we want to help them develop their net zero strategies, and we want to work together because their success is our success. And we want to work with other companies and universities for sustainable solutions. You know, there are lots of people doing great things. So we just need to make sure that we're communicating with them and working with them and funding these projects where we can. We also need to ensure upskilling. So roles are changing so fast, and we believe that this is a responsibility that we have to help in this transition. And the last bit, clients are so crucial. You know, we could get everything right, but if a client doesn't want or can't afford a net zero option, we need to work around that. So we need to provide our clients with all of the important information they need to help them make the best decisions that they can. But if net zero isn't something that they can do now, we want to set them up so they can make those changes when they're ready in the future. And that leads me to digital technology. So I think digital tech has the biggest potential for reducing our emissions. At the moment, we're focusing on how we can utilize the digital twin. For those who don't know, the digital twin is essentially a virtual replica of a building. And with that, you can know every detail. So for example, light bulbs, you can know how many light bulbs are in the building. You can see when they were put in, you can see the manufacturing company, date, etc. This allows you to see real-time performance. You can monitor energy use in hotspots, and then use that data to change BMS systems to improve that. And then it also allows us to learn the successes and failures of the buildings we build, and then take those lessons into our next projects. And then also it allows us to build with the future in mind. So again, if a client isn't ready to be net zero, utilizing the digital twin will allow them to make those changes in the future when they're ready. And I don't want to go too over my time, but I just wanted to mention the use of modern methods of construction, which is offsite manufacturing or prefab. So this building offsite can help us reduce our emissions during the construction process. It helps us reduce the amount of materials that are needed to begin with. And when you're looking at modular building, I think we can use that to improve designs, and the interiors can be personalized, the facades can be different, and the way they're all put together can make every building individual instead of them all looking the same anyway. But yeah, I just think those are all really important things to discuss. So before I sign off, I wanted to mention that. But yeah, I think that's it from me.
Thank you, Sarah. And I was extremely impressed at the amount you managed to run through there in just 5 minutes or so. So it was a bit there. There's a bit there about the importance of collaboration, the economics of offsetting, the importance of upskilling, understanding client needs, and the role of technology. So they were all things that we can talk about later. So thanks again, Sarah. Next, we're going to go to Ruth Kerrigan, who's the Chief Operating Officer at IES. Ruth, over to you.
Hi there, thanks everybody. Nice to be here. Can you hear me okay?
Yeah.
Great. I should be sharing my screen now as well. Okay, so when I was given this topic by one of my marketing team, I was having to think about what can we actually talk about, because there's an awful lot to talk about in this area, and we've only got 5 to 6 minutes to talk about it. So I decided to pick up on one thing, which is local energy systems. So how do we actually, what are the tools that we can use to actually help us to move away from carbon offsetting? But before we even start talking about that, just bring in this concept of, sorry, just get rid of this concept of sustainability. We all know what sustainability is, and just to try 2 things there that kind of link in with this is, we all know this, sustainability is meeting our own needs without compromising the ability of future generations to meet their needs. And also within that, it's about using natural resources to help us achieve that environmental sustainability. There's a lot more than that, obviously, but just thinking of those kind of 2 things. Because how does that fit in with this concept of the local energy system? So if we want to truly move away towards local or towards carbon offsetting, for me, what we really need to start looking at is how are we utilising our own local system and the natural resources that exist within that system. And what do we mean by the local energy system? So within the local energy system, that could be a small neighbourhood, a community, an industrial park, you know, a group of buildings together, within a city centre, a block of buildings, etc. There's lots of different ways to define the size of the local energy system. But, you know, once you decide I have a local energy system, this is what I'm considering to be my local energy system, then you can start to analyse it. And within that, you're looking at everything from the buildings within that local energy system to the assets that they might have, to things like wastewater and treatments, to your green spaces, to your infrastructure. And that also brings in the network. So it's not just about the buildings, but it's how the buildings actually work within the network. So we've got our electricity networks, our heat networks, e-mobility, and also things like water and waste. So the local energy system is everything in balance within that system. How can we optimize that most effectively? So coming back to the question then about, you know, carbon offsetting, how do we optimize that local energy system? Within IES, we've devised this approach, which is, you know, fairly simple. It's not rocket science, but it's about how do you actually give communities the tools to help them to do this as well. And that's basically that you start by measuring your baseline. Let's understand our starting point first of all. You know, how are we using energy across our local energy system, and how are my buildings using energy? Where do I have resources available? So what's my starting point? And then let's start looking at what improvements we can make. And I think that the number one thing that we've kind of seen from all of the various projects and research that we've done is that if you don't improve the efficiency of your buildings first, there's just not enough renewables on the planet to actually offset that energy consumption. Buildings account for 40% of global energy consumption. It's absolutely massive. So we have to reduce that figure before we can actually start to integrate any sort of production to offset that energy consumption in the first place. Forget about carbon offsetting, even just to be able to meet the demand of those existing buildings. So the first step is looking at the existing buildings and how do we improve them. And again, you know, there's many things that we can do in our daily lives, from operational improvements within buildings before you even start spending any money on things like shallow retrofit or deep renovation. Then we get into the point of how do I actually optimize my buildings within my network. How do I optimize that with my heating networks and my electricity networks? Where can I bring in local production, and how do I optimize that as a whole? So can I do things like demand response, energy trading, peer-to-peer networks, behind the meter solutions within that local energy system? So how do we get everything to work together to be the best it can be? Within IES, we've developed a number of digital technologies to help kind of achieve these goals. That's looking at everything from you know, simple level of analysis that can go all the way to city scale, down to the very, very detailed buildings that you can model within the software, and everything in between. So you could have a community or a city or that local energy system that has different granularities of data. You have some buildings that are modeled very simply with the data you have, or other buildings that are modeled at a high level of detail, all contribute to telling us that baseline and how we can actually achieve that local optimized energy system.
Sorry, Ruth, there's a bit of feedback. I don't know whether other viewers are getting this as well, but there's a bit of feedback. I don't know whether, is it worth turning off your microphone and then turning it back on again, just to see whether that works, please.
I don't think I've tried, but I think the problem is something to do with my machine and GoToWebinar. I tried to fix this before and failed. So
okay.
Really bad. I can try.
Let's plow on. Let's plow on.
I'm almost done anyway. Yeah. So where IES are unique is we have three things that kind of bring together to make us differentiate from others when it comes to creating digital twins. We have physics-enabled simulation on the left-hand side, which is world-leading dynamic simulation modeling software that models the physics of the building, its energy and its heat and its flows. On the other side, we have IoT and building management system data, or any data that you can get from any sensors in the building. And each of these augment each other. So you're replacing any of the design assumptions or unknown data in a physics model with real data from sensor data. And vice versa, you're using that physics-based model then to actually create some virtual sensor data to cut down on the amount of hardware that you might have to install in the building. And then with that, we link AI and machine learning to allow us to add an actionable intelligence into that model. And this is where we see ourselves as being unique within the world of performance digital twins. And the last thing I'll show, and then I'll see if I can dial in from my phone for the next part, is that the other part of this is that all of this technology can now be actually given to the real world. So we can create these digital twins of cities, like I said, with different levels of information, different levels of granularity, help cities make decisions on what to do. But we can also get the citizens themselves to become active users. So, this is a live screen in the city of Limerick, and it's going to be a public space where citizens can come, they can explore the model, they can explore what's happening with their city, they can see what actions the city are planning to take for decarbonisation, but they can also provide information themselves about their building, for who they are, and what they would like to see happen across their city. So that is me.
Okay, thank you very much, Ruth. That was hopefully the feedback there wasn't too bad, and you could hear what Ruth said, because she said lots of very interesting things about the different ways of optimizing local energy in buildings. You may remember that we had a poll at the start of the session, and we can now reveal the results of that poll. So we asked, where does the biggest carbon reduction opportunity lie within the built environment sector? And as you can see, materials development was the answer that got the highest percentage of respondents, followed by energy use, designed in efficiency, and nobody said micro energy generation. So that might be something we want to talk about later in the discussion. But now I'm going to hand over to Porrick McMorrow and Jeff Southern from IBI. And I think I'm going to go to Porrick first. Over to you.
Hi, Carol. Thank you. I'm just going to share my screen. Sorry, I have to get used to go to a meeting here and find the share screen button. There it is. Share screen monitor 2. On beginning. Okay. You seeing that okay, Carol?
Yes.
Great. Okay, those are really interesting presentations. My name's Porrick McMorrow. I'm an architect with IBI Group, and I really liked what Ruth just put on screen there of the city of Limerick, because that's where I'm speaking from. And I didn't realize we had such an exciting micro energy generation system. I did realize it was ongoing, but I didn't realize how far developed it was with that 3D model that was kind of being spun around on screen. So impressive work. I'm an architect, passive house consultant, and I want to talk. I'm going to speak with Jeff here, who's the director in our UK office. I work remotely in Ireland on projects in Canada and the UK, and I'm a passive house consultant. So a lot of my work is related to achieving net zero ready buildings, which is fabric first and low operational energy. But we realize a big part of the carbon reduction strategy has to include embodied energy. So we're kind of going to split this up a little bit, where I'll talk about the passive house operational energy approach, and then Jeff will go in deeper dive into embodied carbon. And I'm going to use the context of the NHS Wales Healthcare Initiative decarbonisation strategy, and talk about some projects there, some built projects and projects in design. So the reason I think this is a really good example to look at is because of the overarching government strategies in place in Wales, and how they have allowed kind of clarity amongst design teams in what decarbonisation needs to be achieved. And they've been a useful tool in kind of bringing design teams together with a goal and to set the targets for decarbonising. So the strategy is broad, broader than just buildings, but I'm focused on the buildings part because we're working on a number of health and well-being centres for various client groups and mix of stakeholders on the different projects. And the decarbonisation strategy does aim to achieve net zero, and I think just wanted to pick out how net zero is defined. it is, on the context of Team Wales, so it'll be across the whole public sector, a balance to zero. And I think this is a good approach for this this type of. I think it is a good approach, and it aligns with other approaches from NHS England. And I wanted to show this, which I think a lot of people will be familiar with, because this is how we as architects who may not have a full control over how projects evolve and what their targets and goals are, but we can aim to do to prioritize what needs to be done, and we like to see that as envelope first strategies and reducing the demand in the construction and the operation of the building, and then putting offsetting at the bottom of that pyramid of priorities. And that's reflected again then in the UK Green Building net zero definition. And I like this flow chart as well for how we approach a project. Define a scope for net zero carbon. So in the case of Wales, the NHS decarbonisation plan has done that, and I think plans could evolve in all different sectors and organisations with clear scopes like that, and help drive decarbonisation through projects. And then as architects, we focus on reducing construction and operational energy, and I'll talk in more detail about how we do that. And then after you do those two key strategies, renewables and offsetting, and how we make up the next step on that. So interesting to look at the neighbourhood scale and this project here in Newport, which these projects as early leaders in net zero health and wellbeing centres, they're often at the heart of the community. And Ruth was showing how energy community grids could work, and I thought some of her diagrams look similar to this diagram, which is just how a health and wellbeing centre plugs into an existing community and what that could be. So we're designing this to Passive House standards, and we are measuring and actively reducing embodied carbon also. And that is to try and achieve the decarbonisation strategy from NHS Wales. That strategy wasn't in place at the outset of this building, so it's being an iterative process through different projects in Wales. We're seeing how the earlier the strategy is in place, the better the decarbonisation outcomes tend to be. So this project came next and is in the city centre location. So again, another potential for an energy grid in a different scale and context. And just look at the building here on the high street in Swansea. I think interesting to note how this building, also achieving Passive House standards and trying to reduce that operational energy and operation heating and cooling demand. But we are using shading and insulated panels and attempting to achieve a very high level of glazing, as high as is possible, while still maintaining that good level of operational energy. And then the third project I just want to show and talk about the actual the steps towards decarbonising is in Abergavenny, and it's a satellite radiotherapy unit for an existing hospital there, for Neville Hall Hospital. And these are the kind of steps we took, on a project that was already in development. We started to look at what does moving from Part L requirements to BREEAM Excellent, and then proposed and Passive House enhanced options. And so we worked with our mechanical and energy consultant on this to achieve assemblies, and the assemblies generally are creating a better insulated envelope. Then we worked on the effectiveness of mechanical and electrical systems, primarily the HRV here, having to achieve heat recovery, ventilation at a better standard, and then air tightness was the other big step. So I'm just going to kind of talk through those in the key 5 principles that we apply from Passive House and use to achieve the reduced embodied energy, operational energies. Optimal insulation, air tightness. So this is architects and builders understanding exactly where the air tightness membranes and continuity of the envelope are. And a big part for designers, thermal bridge-free building, and all this is aiming to reduce the heating and cooling loads of a building. passive house windows and doors, so that means high performance envelope again, but also optimization of their orientation and location, and then adding the heat recovery ventilation. So just an idea in Wales, in the Abergavenny, what a wall assembly looks like and how we look at this, and we begin to call out the important layers, which are continuous thermal and continuous airtight barriers. And we do this as practice now for every project we work on. And I think this is really critical for all buildings, new and retrofit, to understand what the building's approach to fabric first decarbonisation through energy use reduction is. You know, offsetting an inefficient building is never going to work. I think other speakers have mentioned that. So the first step for me is looking in detail at how buildings are working, how heat is flowing through the building, and how they can be brought to their most efficient. So these are the type of studies we're doing. It means, you know, rethinking how we install windows, for example, so that that window is less of a thermal bridge, particularly in repeating elements like this, which happen multiple times throughout a building's skin. We need to be looking at you know, getting them optimized and working efficiently. Some of the other studies we do are about how shading can work, and these are studies we'll do in-house in a Revit model. You know, and then I just wanted to kind of show this slide, which is the interior of that same space we studied, to show that, you know, achieving a decarbonized building can still be a beautiful space, a beautiful experience for the people in there. And it's just about understanding this new context that we're working in, which is the context of delivering buildings which, you know, are part of a piece of climate action, helping achieve decarbonization. And so that's kind of the operational side, and I'm going to hand over to Jeff now to talk about how we looked at embodied carbon. And these are the studies we did for that same project, and how we went through a kind of an analysis of different potentials of different materials, and what those would achieve.
Thanks, Warwick. I think we've touched on, and I think probably starting with Ruth's presentation, the previous one, the key elements of energy use. So operational energy is one thing, and people are making good moves and targets towards that. So if you go through the leaner, greener principles in order to reduce your consumption and then apply the decarbonized grid, you can see that there is an obvious opportunity there to achieve the operational zero, certainly, you know, with effort within the target time frame. But I guess for me, I'd like to widen out to talk specifically about the embodied piece, which is that obviously anything you do is by definition carbon heavy. And so although we're seeing, and I've included diagrams here which I love from Letty, and there are obviously other versions and different presentations of those through the WGBC and through REBA, which look at embodied carbon and what the potential is for reducing that by changes in specification and changes in procurement. But as you see from that, you know, you're looking at reductions somewhere in the region from 100% to 60%. And although that's a huge benefit and a big step forwards, it's still the equivalent of, if you build two of those buildings, having the same carbon footprint as one less embodied version. So what you've got to start looking at in terms of the whole life net zero approach is what the lifespan is of the pieces of that building and what their impact is. And the WGBC methodology is that is offset early on as part of the production process. And then you'll see the benefit later on at recycling level. And so I think what I'd like to kind of push for in terms of this debate is how we address recycling, dismantling, disassembly of buildings, how we reuse those pieces of buildings to ensure that how we do it properly in order not to have to destroy them in order to remake them, and how we then reincorporate those in buildings going forwards. So that will hopefully address 3/4 of the remaining 40% of the embodied figures. And then, and only then, should we be looking at things that address offsetting in its wider sense. So how we include things like the Team Wales approach that Porrick mentioned earlier, about how we embody, how we sequester carbon in the wider landscape. And I think that obviously a lot of these projects that are shown and projects that are shown more widely are very limited footprint and address particular needs on a particular site. But if we've decided the building needs to exist, if we've decided that it's a new building and it needs new materials or recycled versions of the new materials, then we need to be looking at what we can do in the wider country or world in order to offset that globally, with the knowledge that 100 or 200 years down the line, we will get that carbon back and be able to reuse it in the built environment long term. Thanks.
I did it again. Thank you very much, Porrick and Jeff. Some specific learning there about sustainable solutions and techniques, but then we brought it into a wider context right at the end, which I quite liked. We've now got around 20 minutes or so for some questions. So if I could bring the panel back in for the debate. Do remember, everyone, that you can ask the panel a question by using the questions function on the right-hand side of your screen. But I'm going to kick off, and I think the first thing I want to talk about really is digital technology and the role that plays in the built environment's drive towards net zero. So a couple of the panelists talked about various bits of technology, but I just wondered, what do we have to do to ensure that we're taking full advantage of technological opportunities, and that we don't make mistakes in choosing the wrong technological solution? So I just wonder whether there's any tips around that. Maybe if we go to Connor first on that, please.
Tips. I mean, it's quite a wide area. Actually, I'm having some really good debates recently. It might be a slightly different answer to what you're expecting around smart buildings. And I think, yeah, we've got a full MEP, mechanical electrical department in Masons. It's definitely where we're seeing the shift. We're going to meet clients and actually trying to really sell the benefits of actually going for a full smart building. And I'm not going to pretend that I am a complete expert on that, because when I do get into quite detailed debates on it, there's looking at the BMS systems and how the actual building in operation, the opportunities there, and it's the technologies available now. It's quite interesting. I heard from one of our head of MEP just yesterday. I was talking. He said started engaging with some of the suppliers, saying when is this technology going to be available? And it's available now. It's just maybe we're not actually capitalising on it. So I've seen some projects where clients have really pushed it from the outset, and making sure that for universities, for instance, you can save a huge amount of operational energy by making those buildings like truly smart. So linking all the lighting systems to Bluetooth lighting systems and tracking it live, and then also making sure that if anything needs maintenance, that you get like live reports, so you're not leaving systems running inefficiently for periods until you're due to do another maintenance update. And then also in commissioning as well. I think the old-fashioned way of walking around the building and tapping it, turning it on and off, checking it works is going to go. I think again, the way we commission and hand over buildings is changing so fast, and I think for the businesses and companies that invest in that now, we'll see the benefits of it. So hopefully that's along the lines of what you're asking.
Well, to be fair, my question was quite sort of deliberately broad. Does anybody else want to come in on this question of technology and how we maximize technological opportunities? Maybe Sarah?
Yeah, I think at the moment, the thing that's probably holding us back the most is the cost. There is a larger upfront cost when you're implementing stuff like the digital twin. It may, in the long term, save you money, but I think that's the one thing that's holding us back. And also, I think our clients may not be as aware of it as they should be, and that's partially our own fault as well, I think. We really need to sell it as well. even though it will be more expensive, I think we need to say, yes, upfront costs may be more, but these are the potentials in the future and will save you money in the long run.
Yeah, and do you think people will ultimately get on board with that message? If, I mean, how would you persuade them to sell that message?
Well, I think it's always kind of been the same thing. I mean, energy, you always try and sell, if you're more energy efficient, your costs are going to be lower. I think it's the same argument, just a bit more complicated now. That's something that I'd probably let our digital team do, because same with Connor, I'm not as versed in digital technology as our digital team. But yeah, I think I would leave it to them.
Yeah. Okay, does anybody else want to come in on that point before I move on? Ruth?
Yeah, can you hear me okay this time?
It's better, yeah.
Yeah, okay, thanks. Yeah, I think when it comes to digital technologies, I think actually the key is interoperability. There's so many digital technologies now, and Sarah's absolutely right. Like, people are choosing them because they add a benefit. So whether that's a value in the construction phase to help you speed up construction or reduce cost or something like that, like, you're going to choose the digital technology based on your needs. But if we actually want to advance how we, construct buildings right through from the design to their end of life, all of the various really good tools along that whole building life cycle, if they can all work together, that's when we can start to create opportunities like creating digital twins at lower cost. So if the BIM model can work seamlessly with the energy model, which can work seamlessly with the procurement practices, to tell us that during the construction, if I'm going to swap out a material or a system, that it's going to have an impact on the building during the operational phase, then we can make better decisions along those various stages of the construction life cycle, which ultimately will help us have better performing buildings at the end of the day. So I think digital tools are going to continue to evolve, but as they evolve, we need to make sure that they're interoperable and there's data sharing between tools to allow us to kind of achieve those goals.
Okay, and does anybody else want to add, Parik or Jeff? Yeah.
Yeah, I guess I'll just add, it's the carrot and stick, isn't it? So it's return on investment. So you get trailblazers, particularly as Ruth said, before you get interoperable systems. You get trailblazers in individual areas, and they show returns on investment for their particular model. So if that's reported back to the wider industry, then they're picked up and delivered to the wider industry. And then the other way that things happen more and more is if they're legislated. So if there's wider pressure coming from the other side in order to deliver it. So with bigger organizations like the NHS or the other kind of grander stakeholders, if they're obliged to do that, then the lessons will come from their implementation and trickle down across throughout the wider industry.
Okay, thank you, Jeff. I think what I'll do, I think I'll move on to another question. Audience member Sophia Brockman-Smith wants to know, what do you think is the most promising, scalable and sustainable alternative to concrete? Who fancies taking that one on? Connor? Connor looks keen.
Just to keep a little bit, I mean, it's not an alternative to concrete. It is kind of concrete. It's actually an alternative to cement. But I mentioned it on there about this exciting geopolymer cements coming out now, which you don't need Portland cement anymore, and it's just coming. I mean, we're using it in temporary works up until now, and it's really heavily used in Australia. There is a debate around the supply of sort of GGBS and waste products. Is that going to run out? But I think especially for the next few years, we'll see a big shift in using sort of alternative to standard concrete, which have a massive reduction in embodied carbon. So yeah, that's my little piece.
Does anybody have any other suggestions for promising, scalable and sustainable alternatives to concrete?
I think this is, I mean, with concrete and steel, I think those are the two biggest ones. But concrete is kind of hard to replace. I think there are universities and companies working on more sustainable concrete using recycled aggregate or recycled concrete and other things that I'm not well versed in. But I think it's also how we build as well. I know we're looking at, how we can use timber frames to reduce the amount of concrete being used in the first place without compromising the structure of the building. So I think at the moment it's more about minimizing the amount of concrete that we're using, and modern methods of construction can help with this as well. But yeah, I think it'll be really interesting to see if anything happens in the next 10, 15 years, if we can find a good, proper working alternative to concrete.
Okay, thanks, Sarah. I think Jeff, you raised your hand briefly there.
Yeah, I think, I mean, it's, maybe controversial to say this, but almost everything is an alternative. If you're creative enough and you do it well, the key reason that concrete is listed as one of the horrors is because it's difficult to decommission. So not only is it difficult from the beginning for all of the extraction reasons, but then once you've used it, how do you then continue to use it? And the degradation, the sort of in scientific terms, that you lose at every point of the process. And so if there are systems that are much more dismantleable and reusable, then you'll see those huge benefits in terms of your long-term embodied footprint. And as soon as we can do that, then we'll see that. The other thing, I guess, is expectation of building size. So, do we really need to build 58 stories when we could build 42 and deliver it in a different methodology?
Okay.
That's quite an open question, but
yeah, I think I just add slightly to it. I think there's a big opportunity for designers and contractors to partner up with this to change the way that clients and end users see buildings. I think, touching on what Jeff said, I don't know, trying to liven the debate up, but we're all aligned. That's the challenge, is that I'm seeing more and more clients, and hopefully this grows momentum, we're not wanting a shiny new perfect finish. Sometimes the specification on concrete, if you want it perfect, it does have a higher embodied carbon content of that. And Jeff's saying one of the things we're trialing to do with these concrete panels is actually make them fully dismantleable. So then in even some office buildings in London may only last 20, 30 years, which is pretty scary to see a building that it's gone up and then in your lifetime it's coming back down again. But you almost want to be feeling guilty if you see new products being used in your projects. So designers definitely, a smaller scale thing is raised access floor tiles. This is something that we've been really, if you had a shiny new raised access floor, all like shiny surface, you should really be questioning. There's piles and piles of reused, second-hand ones that we can take out of buildings. We rip them out daily, so we should be refurbishing them and reusing them. Then clients should start to actually say, I want to see some scuffs and marks on them. You're going to be putting carpet tiles on them anyway, but it's almost that change of mindset to say not have everything too shiny and new, and actually reuse stuff. But there's a little way to go before that's a reality, I think.
Yeah. Okay, sure. Well, Ruth, did you have anything to add on that?
Yeah, I mean, it's been a while since I've been in that space, but I'm pretty sure there's pretty tall buildings now being made from timber, right? So I think we are moving away from concrete. I think the industry itself probably has a lot to do to move away from those sorts of materials, and we're very reliant on it. But I think we are seeing that, especially with modern methods of construction, as Sarah said.
Okay, thanks, Ruth. I think what I'll do now is just go back to our extremely scientific poll that we ran ran at the start of the session. We asked where the biggest carbon reduction opportunities lie, and nobody said micro energy generation. And I just wondered whether, I mean, it's obviously I think people could only pick one, and the other the other options were material development, energy use, designed in efficiency, but nobody said micro energy generation. And I just wondered what the panel thinks the opportunities for micro energy generation is. Is there a big carbon reduction opportunity there, or is it kind of on the periphery, really? So who fancies talking about that first?
I'll start with that one if you want. I think micro energy generation is key to it goes back to what I was saying about the local energy system, and it's we can't deal with one building at a time. We have to look at buildings as communities and look at them as groups of buildings. and how do we actually get them to work together and to use the resources available to them. And that brings in that concept of sharing. I think microgeneration, whether it's for a single building or maybe for a group of buildings, is going to be key to that. The project we're doing in Limerick, actually, for Padraig's info as well, is actually looking at creating positive energy blocks. And that's looking at generation from local sources like PVs on the roof, but also a tidal turbine that's going in the river adjacent to the block. So that's a form of microgeneration that's going to service the block. And we investigated other things like CHP. There's actually a hotel in Limerick that's using CHP for their hotel. And they're also looking at how do they expand that out to work with a number of buildings as well. So I think microgeneration is absolutely critical to achieving decarbonisation of the built environment in general.
Okay, does anybody disagree with that or have a different take on that?
I agree and disagree. So I think of all of the decarbonisation pieces, the decarbonisation of the whole grid is the fundamental piece, because that's where the bulk of the energy is currently delivered. And if that happens with the progression that we would like to see, then microgeneration is still valid and will still serve those buildings well. But what it won't do is provide a different degree of decarbonisation necessarily. It will provide an equally decarbonised energy. So what's good about it is it's locally delivered. I mean, that's a fundamentally good way to deliver it. But it doesn't discount energy production at scale in a decarbonised fashion.
Okay.
Sorry, Carl, and ended that slightly too soon before you.
You did, yeah. Does anybody else want to come in on that point?
Just yeah, I would go back to the energy communities. I think that idea, because there's different building typologies, has a lot of power where, especially in a dense city centre, there's not going to be as much opportunities to add renewables to buildings. There's only limited rooftop space, but often you find at certain densities there's lots of rooftop space available nearby. Like we've seen some of the Welsh projects, for example, had residential development where you could imagine a load of solar arrays happening on houses, and those people making money selling energy to their local health centre and kind of being engaged in an energy community in that way. So I do see a lot of power in that. But I'd be interested to hear response to Jeff's point there, that why is it better to do it at the grid technologically compared to doing it at the community level? Is there less carbon if it's done on either of those scales? That'd be a question for Ruth.
I think the issue is, I actually agree with you, Jeff. I think it's both. It's everything. But I think the issue is that if you produce the energy locally, in simple terms, it's got less distance to travel to the building that needs it. If you produce it on a wind farm outside the city, then you're going to get losses by transferring that to the city. But it is both. It's not a case of, you can't. We should be using microgeneration to reduce the need, because I can speak from Ireland and a lot of detail, and this is the UK. We're after shutting down peat plants. They're starting to shut down the fossil fuel generation plants, but they haven't caught up on how much wind and renewables there is to allow for the growing needs on the electricity side. So we're facing into a future where there's probably going to be blackouts as a result of that. Now, the question I'd raise is that a reason not to shut down the peat plants? I don't think so. Because if we always say, oh well, we can't shut down the peat plants because we need more renewables, we'll never shut down the peat plants. So at some point we have to just do it, and then we have to start for other solutions that can supplement. So I think that's where microgeneration comes in. It's not a case that it's going to be the final solution, but it's helping to reduce the demand that you then need from those larger plants outside the cities that are, from wind or tidal or other sources.
Okay, thank you, Ruth. Unbelievably, I think that's about all we've got time for, as it's about 2:30. But thank you very much to Sarah, Ruth, Connor, Padraig, and Jeff. It's been a fascinating discussion, and this session will be shortly available to watch or rewatch on demand. And there's lots of other net zero live activity and sessions, think pieces, discussions over the next couple of days on building and housing today. So do look out for all of that. But thank you very much again to everyone, and goodbye.
Thanks.